So let's go on to 13.4. And I think this is what I had done really was most of what you need for 13.5. So this is really 13.5 type stuff. I've covered everything you need to know to do the homework of what I assigned. So stick to what I assigned. I think I said this was, I don't know where I left off. 13.2. I didn't see 13.3 in there, did you? There it is. Okay, so arc length. And then, okay, so all this stuff on the unit normal vector and all that, that's more like 13.4, 13.5. We're not doing 13.6, so don't worry about that. But what I haven't done basically is curvature. So I'll hit everything. This next concept is curvature. And that's an important concept to go over. So let's talk about that. So curvature definition says this. So let C be a smooth curve given by R of S. This is where it gets kind of weird, but don't worry, the calculations aren't that bad. Given by R of S, where S is the arc length parameter. So it's not really, I mean, it's kind of a strange result when you think about that. But I'll try to describe it as we go, what this means. The curvature at S is given by, and we use K. The book might use kappa, but it's really just a K. Don't worry about it. It's the magnitude of dt ds. So it's the magnitude of the rate of change of the unit normal vector with respect to the arc length. Okay, and I'll try to describe that. So it's t prime of s. That's just the same notation, just different notation. Where t is the unit tangent, the unit tangent vector. T is the unit tangent vector. Rate of change of the unit tangent vector with respect to not like time, but the arc length, the length that it traveled or length that you increment. Okay, so what this does basically, this measures how sharply a curve bends. So, and then I have this written out. Let's go ahead and just find it in the other one because it's a little easier. Let's just show you the rest of the stuff. Here it is. Okay, so we'll talk about it. I'll do some more examples, but this is basically what I want to do next. I don't want you to worry too much about this one because you'll be able to use the formulas and any sort of future stuff. You can look back on it, so it's okay. So let's go through this. Oops. All right, so I just wrote that. Okay, so measures how, I'll just leave it like that, I suppose. It calculates the magnitude of the rate of change here, calculates the magnitude of the rate of change of the unit tangent vector with respect to arc length. So what it's doing then, like take a look at this curve that I drew or drew before. So this here and here. Which would you say has more like curve to? Which one is sharper? Like how sharp is it? What's a sharp curve? Like this curve is not as sharp as this curve. We would all agree with that. The analogy I like to use is like an off-ramp. I've actually seen signs that say increasing curvature when you get off an off-ramp. And it's like you don't really want that to happen. Like picture an engineer going, you're getting off an off-ramp. Well, if it turns sharper all of a sudden, well then they're flying off the off-ramp because it's an increasing curvature. So I've actually seen those signs and I wanted to take a picture so I could show my classes this, but that's curvature. So we know this, we would all agree, is like has less curve to it than that. So this is pretty sharp, but it depends on the distance, right? I mean, it's all about how quickly it does it. So as you go around, we want a way to describe it. So it's how this magnitude is changing with respect to how much you turn it, like how much you're turning. So that's what the calculation is telling you. And if it doesn't totally make sense, that's okay. It is kind of weird. But just know how to use the calculation formulas in the text. So I might ask you to just calculate the formula and calculate it out. This is the example I usually give. And calculate that, try it, okay? Try it. It takes a while. The stuff will simplify, but it does take a while. And since this is a shorter video, let's see if I can find it in my old notes. Let's just go back here. So here's all your stuff. You can look at this. So what was that, 13 something? Let's see. You can see 14, 13.3. Arc length and curvature. There's the arc length formula. There's the theorem. Prove that one. Y perpendicular. Okay, so I don't really see it there. Okay, so that's curvature would be next. So let's try to find 13.4. 13.3. I might have just looked at it. 14. 14.4. I know I have a lot of 75 stuff, don't I? I know it's in here. Let's just sort by name and see if I could find it. There it is. So curvature, here's the curvature. These are my old notes, obviously. And so that's an example. I think that's it, right? There's an example. More examples. Motion. So we didn't do any of that right now. So I think, is that the example I gave you? I don't know. I think it's this one, actually. So it looks like I have the solution. I don't have it written out. So you can take a look. We'll just copy this over. See if this makes any sense. Hey, it's better than nothing. Okay, so you can do those calculations. Usually it's kind of straightforward stuff. I wouldn't worry too much about it. Okay, I'll just paste it down here. All right. So just some more examples to do. To find curvature. You find n and t. So here's r, r prime, t, etc. So you can work all those out. It's an example to take a look at. Okay, that'll do it.